Welcome to the Channel Science documentary for sleep. I'm glad you're here, in whatever way you're here awake, tired, drifting, or already half asleep. There's nothing you need to do, nothing you need to hold on to. You can listen closely, or you can let the sound pass through you. You might notice your breathing slow a little, or your body settling into whatever position it's found. And that's enough. Tonight, we're exploring the universe, not rushing through it, not trying to grasp it all, just letting its facts and images move gently by, like distant lights. The universe is vast in ways that are difficult to fully picture, even when we're wide awake. It holds galaxies made of hundreds of billions of stars, drifting slowly apart. It holds black holes where gravity bends space itself. It holds clouds of gas and dust where new suns are quietly forming, and long, dark stretches where almost nothing seems to happen at all. Everything we'll talk about tonight is real. These are not myths or metaphors, even when they sound like them. Astronomers have measured the light, traced the motion, listened to the faint signals that arrive here after travelling for millions or billions of years. As you listen, you might feel wonder, or calm, or nothing in particular. Your attention may sharpen for a moment, then soften, then fade again. That's natural. You don't need to remember every detail, or any detail at all. If you'd like to stay with me, I'm here, and if you drift away for a while, the universe will still be here when you return. The universe is expanding. The universe is not standing still. On the largest scales we can measure, space itself is stretching, slowly and steadily, carrying galaxies away from one another. This expansion is not like an explosion from a single point into empty space. Instead, it happens everywhere at once, with every large region of space gently increasing its distance from the others. When astronomers look at distant galaxies, they see their light shifted toward redder wavelengths. This redshift is a subtle stretching of light, matching the stretching of space it travelled through. The farther away a galaxy is, the more its light has been stretched, and the faster it appears to be moving away. This relationship is consistent and calm, like a quiet rhythm repeated across the sky. It can help to imagine dots drawn on the surface of a balloon. As the balloon slowly inflates, each dot moves away from every other dot, even though none of them are moving on the surface itself. In the universe, galaxies are like those dots, carried along by the expansion rather than racing through space on their own. This expansion has been happening for billions of years, ever since the universe was hot, dense, and much smaller than it is now. Over time, distances grew vast. Light that began its journey long before Earth existed is still arriving, carrying faint information from a younger universe. There's something quietly reassuring in this motion. The universe expands without urgency, without pause, simply continuing. You might notice how that steady outward drift feels slow, patient, and unconcerned with being observed, and then it settles, without asking for anything in return. Galaxies are held together by invisible mass. Galaxies are enormous collections of stars, gas, dust, and planets, bound together by gravity. But when astronomers measure how fast galaxies spin, something unexpected appears. The visible matter alone isn't enough to hold them together. Stars at the outer edges move too quickly, as if more gravity is present than we can see. This unseen influence is called dark matter. It doesn't emit light, reflect it, or absorb it in any measurable way. Its presence is known only through its gravitational pull around each galaxy. Dark matter forms a vast halo, extending far beyond the visible stars, shaping how the galaxy moves and holds together. In images and simulations, galaxies sit inside these halos like lanterns inside invisible spheres. The stars trace graceful spirals or soft ellipses, while dark matter quietly provides the mass needed to keep everything bound. Without it, galaxies would slowly drift apart, their stars escaping into intergalactic space. Dark matter outweighs ordinary matter by a wide margin. Most of the mass in the universe is dark, silent, and unknown in composition. It does not interact with us directly, yet it plays a central role in forming galaxies, clusters, and the large-scale structure of the cosmos. There's a gentle humility in this fact. Most of what shapes the universe cannot be seen, even with the most sensitive instruments. It reminds us that presence doesn't always announce itself, and influence doesn't require visibility. The universe carries much of its weight quietly, and that quiet can feel steady, even comforting. Light takes time to travel. When you look up at the night sky, you're always looking into the past. Light moves fast, but the universe is very large, and even light needs time to cross it. The moon's light takes a little over a second to reach Earth. Light from the sun takes about 8 minutes. Light from distant stars can take hundreds or thousands of years. For galaxies beyond our own, the journey is longer still. Some of the faint smudges seen through telescopes are so distant that their light began travelling toward us billions of years ago. That light started its journey before Earth formed, before the sun existed, before our galaxy had its current shape. Astronomers use this delay as a kind of natural time machine. By observing very distant objects, they study earlier stages of the universe. Younger galaxies appear smaller and less organised, still assembling themselves through gravity and motion. Over time, structure emerges slowly, not all at once. This means the universe does not present itself as a single moment. It arrives layered, with many eras visible at once. Nearby stars show something close to the present. Distant galaxies show deep history. All of it reaches us together, quietly, as light. You may notice how this stretches the idea of now. The universe doesn't insist on immediacy. It allows vast delays, long journeys, and patient arrivals. Even if your attention wanders, the light keeps coming, unbothered by whether it is noticed the moment it arrives. Stars are born from clouds of gas. Stars are not eternal. They form, they shine, and eventually they change or fade. Their beginnings are found in large clouds of gas and dust, known as nebulae, drifting through galaxies. These clouds are cold and diffuse, spread over many light years, barely noticeable until gravity begins to work. Over time, small regions within a cloud grow slightly denser than their surroundings. Gravity pulls more material inward, increasing pressure and temperature at the center. As the region collapses, it spins, flattens, and heats. Eventually, the core becomes hot enough for nuclear fusion to begin. When fusion starts, a star is born. Hydrogen atoms merge into helium, releasing energy that pushes outward, balancing gravity's inward pull. The star settles into a long, stable phase, shining steadily for millions or billions of years. Around young stars, leftover material can form disks, where planets, moons, and smaller bodies may slowly assemble. In this way, stars are not isolated events but beginnings of systems, environments where structure and motion continue to develop. There's a softness to this process. Starbirth is slow, gradual, and hidden within clouds. It takes patience for light to emerge. Nothing rushes. The universe allows its most luminous objects to begin in darkness, gathering quietly until they're ready to shine, and even then, they shine without asking to be seen. The universe is mostly empty. Despite its size and richness, the universe is largely empty space. Stars are separated by vast distances. Galaxies, too, are far apart, with immense regions between them where matter is sparse and motion is minimal. Even within galaxies, most of the volume contains almost nothing at all. This emptiness is not a flaw or a gap. It's a defining feature. Space provides room for gravity to shape structures slowly, for light to travel, for systems to remain stable over long periods. Without this emptiness, the universe would be crowded, chaotic, and short-lived. In intergalactic space, atoms may be separated by meters or more. Temperatures are close to absolute zero. Time passes with very little change. These regions are not truly nothing, but they are quiet in a way that's difficult to imagine from everyday life. Emptiness allows motion to be gentle. It gives stars room to orbit, galaxies room to drift, and light room to travel uninterrupted for billions of years. The universe does not fill every corner with activity. It leaves space. You may sense how that vast quiet mirrors something familiar. Not every moment needs to be filled. Not every space needs content. The universe seems comfortable with openness, with distance, with stillness, and it carries that calm forward, whether or not anyone is paying attention. Time moves differently depending on motion and gravity. Time does not pass at the same rate everywhere in the universe. According to relativity, clocks tick differently depending on how fast they're moving and how strong gravity is around them. This isn't a metaphor or a thought experiment. It's something measured and confirmed, again and again. A clock on a fast-moving spacecraft runs slightly slower than one at rest. A clock near a massive object, like a planet or a star, runs slower than one far away from gravity's pull. The differences are small in everyday life, but they become significant near objects like neutron stars or black holes, where gravity is extreme. This means the universe does not share a single, universal time. Instead, time is local, shaped by motion and mass. Each region carries its own pace, its own gentle rhythm of seconds and moments. Satellites orbiting Earth experience this effect. Their clocks must be adjusted to keep systems like GPS accurate. Without accounting for time's flexibility, navigation would slowly drift off course. Even here, close to home, time quietly bends. There's something tender in this idea. Time adapts. It responds to where it is and what surrounds it. It isn't rigid or demanding. If your own sense of time feels stretched or softened right now, that fits comfortably within a universe where time itself is willing to slow down. Black holes are regions, not objects. A black hole is not a solid thing floating through space. It's a region where gravity has become so strong that nothing inside can escape. Not even light. This region forms when a large amount of mass is compressed into a very small volume. At the boundary of a black hole is the event horizon. Crossing it doesn't feel special from the inside, but from the outside it marks the point of no return. Beyond it, paths through space all lead inward. Despite their reputation, black holes are not cosmic vacuum cleaners. They don't roam the universe, swallowing everything nearby from a distance. Their gravity behaves like that of any other object with the same mass. Stars can orbit them peacefully, sometimes for billions of years. At the center lies a place where our current understanding breaks down. Equations lose clarity. The laws of physics grow quiet and uncertain. This isn't danger so much as mystery, a reminder of the limits of knowledge. Black holes show that the universe contains places where answers thin out, and still, the universe continues calmly around them, untroubled by the unknown. You don't need to resolve every mystery to remain at ease. The universe has a background glow. Everywhere in the universe, there's a faint microwave glow known as the cosmic microwave background. It's the leftover warmth from a time when the universe was much hotter and denser than it is now. Shortly after it began expanding, as the universe grew, that intense heat stretched and cooled, its light lengthening into microwaves. Today, this radiation fills space evenly, arriving from all directions with remarkable uniformity. Sensitive instruments can detect tiny variations in this glow, small differences in temperature that reflect early density fluctuations. Those subtle patterns eventually grew into galaxies and clusters, guided by gravity over immense timescales. This background is quiet and persistent. It doesn't announce itself. It's simply there, a gentle afterimage of the universe's earliest moments, still present after billions of years. There's comfort in knowing the universe carries memory so softly. Its earliest light hasn't vanished. It's thinned, cooled, and settled into the background still present, still travelling, still available, whether noticed or not. Elements are forged inside stars. The atoms that make up your body were formed long before Earth existed. Hydrogen and helium came from the early universe, but heavier elements were created later, inside stars. In stellar cores, fusion builds elements up to iron. When massive stars reach the end of their lives, they explode as supernovae, releasing enormous energy. In those moments, even heavier elements are formed: gold, iodine, uranium, and scattered into space. Over time, this enriched material becomes part of new stars, planets, and eventually living systems, matter cycles. Nothing is isolated from what came before. This process unfolds slowly, across generations of stars. Creation is not a single act, but a repeated one, layered and patient. The universe does not rush its materials. It allows them to be remade, redistributed, and reused. Everything solid carries a long, luminous history, and that history rests quietly within it. The universe has no known center. There is no central point in the universe that everything moves away from. Expansion happens everywhere at once, from any galaxy. Others appear to be receding, each observer seeing themselves as central. This can feel counterintuitive. We often imagine space expanding into something from somewhere. But the universe doesn't require an outside or an edge to grow. Every location participates equally. No place is privileged. No viewpoint is required. This idea removes hierarchy. The universe does not organize itself around importance. It simply expands, evenly and impartially. If you ever wonder where you fit, the universe offers a gentle answer: wherever you are is enough. There is no need to be at the center because, in a way, every place already is. Most stars are smaller and cooler than the sun. The sun feels large and powerful from Earth, filling the sky with light and warmth. But in the context of the universe, it is fairly ordinary. In fact, most stars are smaller and cooler than the sun, quietly burning their fuel at a gentler pace. These stars are called red dwarfs. They glow faintly, with a deep reddish colour, and they make up the majority of stars in our galaxy. Individually, they are easy to overlook. Together, they shape the Milky Way. Red dwarfs burn their fuel slowly and efficiently. Some are expected to shine for trillions of years, far longer than the universe has existed so far. While larger stars live fast and end dramatically, these smaller stars persist, steady and enduring. Many red dwarfs host planets. Some of those planets orbit close enough to receive warmth, raising quiet questions about habitability. Not answers, just possibilities, drifting gently through astronomical catalogues and long-term observations. There's something unassuming about these stars. They don't blaze or dominate. They simply continue, providing light in small, consistent amounts. The universe seems comfortable relying on modest sources, repeating them often, letting longevity matter as much as brilliance. Gravity travels at the speed of light. Gravity feels immediate in daily life. When something falls, it falls now. But gravity does not act instantaneously across space. Changes in gravity move at the speed of light, just like electromagnetic signals. When massive objects move or collide, they send ripples through space-time called gravitational waves. These waves stretch and compress space itself as they pass, incredibly faint by the time they reach Earth. Scientists detected these ripples for the first time, using instruments sensitive enough to measure changes smaller than an atomic nucleus. The signal came from two black holes merging over 1 billion years ago. That event had already finished long before Earth had complex life, yet its motion arrived here, softly, as a passing vibration in space-time. Gravity carries news patiently, it doesn't hurry. Even the most violent cosmic events arrive as whispers by the time they reach us, reminding us that distance softens everything. Galaxies collide without stars touching. Galaxies frequently interact and merge over cosmic time. These encounters sound dramatic, but they are surprisingly gentle. When galaxies collide, their stars almost never hit one another. The reason is space. Stars are separated by vast distances, even within galaxies. During a merger, stars pass by each other like drifting motes, their paths altered by gravity rather than impact. Gas clouds behave differently. They can compress, heat, and trigger bursts of star formation. New stars ignite, briefly brightening regions that were once quiet. Over time, the galaxies reshape themselves into new forms, spirals becoming ellipticals, structures smoothing out, motion settling. These mergers take hundreds of millions or billions of years. There's no single moment of collision, just a long process of influence, adjustment, and rearrangement. Even large changes unfold slowly in the universe, leaving room for calm continuity. Space has a temperature close to absolute zero. In the emptiest regions of space, far from stars and galaxies, temperatures hover just above absolute zero. This background temperature is set by the faint cosmic radiation filling the universe. Absolute zero represents a state where atomic motion nearly stops. Space never fully reaches it, but it comes close quieter than any environment naturally found on Earth. Despite this cold, space is not frozen solid. Particles still move, radiation still travels, time still passes. Cold does not mean inactive, just subdued. The universe does not demand warmth everywhere. It allows wide regions of near stillness, punctuated by islands of heat and light. There's something peaceful about that balance. Activity where it's needed, rest where it's not. A cosmos comfortable with long stretches of cold silence. The universe is shaped by slow processes. Many of the universe's most important changes happen slowly. Mountains on Earth rise over millions of years. Galaxies form over billions. Even light, fast as it is, takes time to cross cosmic distances. This slowness is not inefficiency, it's stability. Gradual change allows systems to endure, to adapt, to settle into lasting patterns. Fast events exist, explosions, flares, collisions, but they are brief punctuation marks in a much longer sentence. Most of the universe is written in long, steady lines. You don't need to keep up with all of it. The universe isn't moving faster than it should. It's comfortable with patience. If your own pace feels slow right now, or uneven, that fits easily within a cosmos built on gradual unfolding. Nothing important is rushing past without you. Planets are more common than stars. For a long time, planets were thought to be rare. Astronomers knew of only those in our own solar system, and there was no clear evidence that other stars hosted worlds of their own. That picture has changed gently, steadily, over the last few decades. Today, thousands of exoplanets have been confirmed, and many thousands more are likely waiting to be identified. Some are large and gaseous, orbiting close to their stars. Others are rocky and small. Some follow neat, circular paths. Others move in stretched, elongated orbits, drifting far out before returning. From these discoveries, a quiet conclusion has emerged: planets are common. In fact, there may be more planets in our galaxy than stars. Many stars host multiple worlds, arranged in systems very different from our own. Some planets orbit in the dim glow of red dwarf stars. Others circle bright suns much larger than ours. Many exist in environments unlike anything we've experienced, with extreme temperatures, thick atmospheres, or strange chemical compositions. This abundance doesn't insist on meaning, it simply exists. Worlds form easily when stars form, as if the universe finds it natural to make places, again and again. You don't need to imagine them all clearly. Just knowing they're there is enough, a quiet widening of what feels possible. Orbits are balances, not paths of force. When we picture orbits, it's easy to imagine gravity pulling objects inward like a tether. But an orbit is really a balance, a steady negotiation between motion and attraction. A planet moves forward through space, while gravity gently curves that motion inward. The result is a continuous fall that never quite lands. The planet is always falling toward its star and always missing it. This balance creates stability. Orbits can last for billions of years if undisturbed, repeating the same quiet motion over and over. Moons circle planets, planets circle stars, stars circle galactic centers, motion layered within motion. Even chaotic-looking systems often contain hidden regularities. Over long periods, patterns emerge, resonances form, systems settle. There's no strain visible in an orbit. Nothing appears to be forcing anything else to comply. Motion and gravity simply coexist, adjusting to each other. That kind of balance doesn't require effort in the way we usually think of it. It's not held together by tension, but by accommodation. The universe seems to prefer arrangements where things can keep going without struggle, moving in ways that allow them to last. Space is not completely dark. When we imagine space, we often picture total darkness, but space is filled with faint light from many sources, starlight scattered by dust, glow from distant galaxies, radiation left over from the early universe. Even between galaxies, photons are passing through, thinly spread but persistent. The darkness of space is not emptiness, it's subtlety. Light is there, just too diffuse to brighten the void. In some regions, clouds of gas emit a soft glow as atoms release energy. In others, dust reflects starlight faintly, creating barely visible structures that stretch for light years. Telescopes tuned to different wavelengths reveal layers of this hidden light. Infrared shows warmth. Radio waves trace cold gas. X-rays mark energetic events. The universe is luminous in many ways at once. This quiet illumination doesn't compete for attention. It simply exists, spread thinly across enormous distances. Even when things feel dark, there may still be light moving through. Not concentrated, not demanding, just present. Motion in the universe is often curved. Straight lines are rare in the universe. Gravity bends paths, curves light, and reshapes trajectories. Even beams of light follow curved routes when passing near massive objects. This bending is not a force acting on light, but a change in the shape of space itself. Massive objects create gentle depressions in space-time, and moving things follow those contours naturally. Astronomers see this effect as gravitational lensing. Distant galaxies appear stretched, doubled, or distorted when their light passes near intervening mass. These distortions help map invisible matter and reveal structures otherwise hidden. Nothing needs to be pushed for this to happen. Curvature arises from presence alone. Mass shapes space, and space guides motion. The universe rarely insists on straightness. It allows detours, arcs, and slow bends. Paths are shaped by context, not by intention. Motion adapts quietly to what surrounds it and continues on. Silence is a real condition in space. Sound requires a medium air, water, or solid matter to travel. In the near vacuum of space, sound waves cannot propagate. Explosions, collisions, and eruptions happen without noise. A supernova unfolds in silence. A star tearing itself apart sends out light, radiation, and particles, but no sound follows. Even dramatic events arrive without audible presence. This silence does not mean absence of activity. It means the universe communicates differently, through light, gravity, and particles, not pressure waves in air. Silence allows events to remain distant in a particular way. Nothing intrudes, nothing startles. Everything unfolds without announcement. You don't need to imagine that silence sharply. It's not empty or tense. It's simply the absence of vibration, a condition where things happen without demanding to be heard. The universe is comfortable that way, letting even its most powerful moments pass quietly. The night sky changes very slowly. When you look at the stars night after night, they seem fixed and permanent. Constellations return in the same shapes. Familiar patterns rise and set with calm predictability. But beneath that steadiness, change is always happening, just at a pace that rarely asks to be noticed. Stars move through space, each following its own long path around the galaxy. Over thousands of years, constellations subtly distort, lines stretch, angles soften. What feels timeless is, in truth, temporary on a very long scale. Even the stars themselves evolve. Some brighten slowly, others cool and fade. A few will end their lives in quiet shedding of outer layers, while others will collapse or explode. These changes are real, but they unfold over spans far longer than a human lifetime. Because of this slowness, the sky becomes a place of continuity. It offers repetition without stagnation. You can return to it again and again and find it familiar, even though it is never exactly the same. The universe seems comfortable with changes that don't demand attention. It allows transformation to happen beneath the surface of familiarity, letting presence matter more than novelty. The sky does not rush to show what it's becoming. Many cosmic events are one-time occurrences. Some events in the universe happen only once. A particular star forms, shines, and ends. A specific pair of black holes merge. A single supernova releases its energy into surrounding space, never to be repeated in quite the same way. These events are not rehearsed. They don't cycle back around. They happen, and then they become part of the universe's history, carried forward as change conditions, altered matter, and travelling light. When astronomers observe distant explosions or collisions, they're witnessing moments that will never occur again. The universe does not preserve copies. It allows uniqueness quietly, without ceremony. And yet, even one-time events rarely feel isolated. Their effects spread slowly, influencing future stars, planets, and structures. Singular moments become part of a larger continuity. There's something gentle about that balance between irreversibility and persistence. The universe doesn't insist on repetition to create stability. It allows moments to pass, knowing that what follows will still have room to unfold. The universe has a chemical simplicity. Despite its complexity, the universe is mostly made of just a few elements. Hydrogen dominates, followed by helium. Everything else carbon, oxygen, iron, calcium makes up only a small fraction by comparison. This simplicity comes from the universe's early conditions. Only the lightest elements formed at first. Heavier ones appeared later, gradually, through stellar processes and rare energetic events. Because hydrogen is so abundant, stars form easily. Because carbon is present at all, chemistry can grow intricate. Small imbalances lead to rich outcomes. The universe does not begin with excess. It begins with very little and allows complexity to emerge over time. Structure grows not from abundance, but from patience. That simplicity remains everywhere, even now. most of space contains little more than thin hydrogen gas. The richness we notice exists in pockets, not everywhere at once. The universe seems content with that, allowing detail without demanding density. Cosmic distances resist intuition. Distances in the universe are so large that familiar units lose their meaning. Kilometers and miles become unwieldy. Even years feel too small. Instead, astronomers speak in light years, the distance light travels in 1 year. Even then, numbers grow quickly. The nearest star system is over 4 light years away. The Milky Way spans about 100,000. The nearest large galaxy lies millions of light years beyond. These scales are not meant to be grasped fully. They stretch imagination rather than filling it. Any picture formed will be incomplete, and that's expected. The universe does not require precise visualization to be real. Its vastness exists regardless of whether it's fully imagined. Knowing that something is far can be enough. Distance creates gentleness. Events arrive softened by time and space. Nothing cosmic is sudden here. Everything takes its time to reach you, arriving already calm. The universe does not appear hurried. Across all scales, the universe shows no sign of urgency. Stars take millions of years to form. Galaxies rearrange themselves over billions. Expansion continues steadily, without acceleration that feels frantic. Even dramatic events are brief interruptions in a much slower flow. They flare, fade, and are absorbed into longer processes that continue quietly afterward. There is no deadline visible in the sky, no countdown embedded in the stars. The universe is not racing toward a finish it needs to reach. That unhurried quality is consistent everywhere we look. Motion continues, change happens, but nothing seems anxious about it. If you find yourself slowing down as you listen, or drifting, or letting thoughts stretch out that pace fits comfortably here, the universe has been moving this way for a very long time, and it does not seem eager to change how it goes. Stars can wander far from where they were born. Stars are often born in clusters, forming together from the same cloud of gas and dust. At first, they share similar paths, moving through the galaxy as loose families. But over time, those connections soften. Gravitational influences from nearby stars, clouds, and the overall pull of the galaxy slowly alter their motions. Stars drift apart, clusters dissolve. Individual stars begin long, solitary journeys around the galactic center. The Sun itself is a traveler. It has completed many orbits around the Milky Way since it formed, passing through regions with different stellar densities and environments. The sky we see today is not the sky it saw long ago, and it will not be the same in the distant future. These migrations are slow and gentle. Nothing is abruptly displaced. Stars simply adjust, responding to countless small influences over immense periods of time. There's something quietly reassuring in that. Origins matter, but they don't bind forever. The universe allows its creations to move on gradually, without severing their past, just extending it into new paths. Some stars are nearly pure nuclear engines. At their cores, stars are powered by nuclear fusion. Under immense pressure and heat, atomic nuclei merge, releasing energy that flows outward as light and warmth. In most stars, this process is steady and balanced. Gravity presses inward, fusion pushes outward. Neither side overwhelms the other for long stretches of time. The star maintains a calm equilibrium. This balance can last for billions of years. During that time, the star does not change dramatically. It shines, it radiates, it continues. The core of a star is a place of intense activity, yet the surface may appear serene. Energy travels outward slowly, sometimes taking thousands or even millions of years to reach the surface. Deep activity does not require visible turbulence. The universe often hides its most powerful processes beneath layers of calm, letting surfaces remain gentle even when cores are alive with motion. Space contains vast magnetic structures. Magnetic fields thread through the universe. They arise wherever charged particles move, from planets and stars to entire galaxies. Around Earth, the magnetic field shields the atmosphere from solar particles. Around stars, magnetic fields shape flares and winds. Across galaxies, faint magnetic lines stretch for thousands of light years. These fields are invisible, but their effects are measurable. They guide charged particles, influence star formation, and shape the behavior of cosmic rays traveling through space. Magnetic structures do not dominate the universe. They do not force themselves into attention. They simply exist, woven through matter and motion, quietly shaping outcomes. The universe often works this way through influences that are present without being obvious. Not everything important announces itself. Some structures are felt only through their gentle guidance. The universe recycles its material. Nothing in the universe is truly discarded. Matter moves from one form to another, passing through stars, planets, clouds, and space itself. When stars exhaust their fuel, they release material back into the galaxy. Some do so gently, shedding outer layers. Others do so explosively, scattering elements far and wide. That material becomes part of new clouds, new stars, and new systems. Over time, atoms may pass through multiple stellar lives, changing context but not essence. This recycling happens slowly and continuously. There is no central plan, no final destination, just circulation. The universe does not cling to permanence in individual forms. It allows change without loss, continuity without stagnation. Everything participates, and nothing is rushed through the process. The universe allows long periods of quiet. For every energetic event, there are long stretches of relative calm, regions of space where little changes, where matter drifts slowly, temperatures remain low, and interactions are rare. These quiet periods are not empty pauses between important moments. They are the dominant state of the universe. Activity is the exception, not the rule. In these vast quiet regions, time passes almost unnoticed. Nothing calls for attention, nothing interrupts. The universe seems at ease with that. It does not fill every moment with motion or noise. It leaves room. If you find your thoughts thinning out, or your awareness softening into something quieter that matches the universe well, most of it has been resting this way for a very long time, and it remains entirely complete. Even empty space has structure. What we call empty space is not completely uniform. On the larger scales, matter in the universe forms a vast, subtle pattern, sometimes described as a cosmic web. Galaxies gather along long filaments, with enormous voids stretching quietly between them. These filaments are made of dark matter and thin gas, gently guiding where galaxies form and how they move. Over billions of years, gravity draws matter into these strands, leaving wide regions comparatively empty. The result is a universe that is neither scattered at random nor packed tightly together. It has shape without sharp edges, structure without rigidity. Patterns emerge, but they remain soft. When astronomers map these large-scale structures, they see repetition, not exact copies, but familiar arrangements echoed across space. Filaments intersect, clusters grow at the crossings, voids remain spacious and calm. This kind of structure doesn't demand close attention. It can be sensed rather than traced in detail. The universe seems comfortable arranging itself gently, letting gravity do slow work over long spans of time, creating order that feels more like drifting than design. Stars are constantly losing mass. Stars feel solid and enduring, but they are always shedding a small part of themselves. Through stellar winds, particles stream outward from their surfaces, carried into surrounding space. For stars like the Sun, this loss is gentle and steady. Charged particles flow outward in a continuous breeze, shaping planetary environments and contributing material to the interstellar medium. In larger, hotter stars, these winds can be much stronger, stripping away significant amounts of mass over time. Even so, the process is gradual. The star remains stable for long periods, losing itself slowly, almost imperceptibly. This outward flow does not weaken the star's presence in a dramatic way. Instead, it connects the star to its surroundings. Matter moves outward, influence spreads. The universe rarely seals its objects off from one another. Even stable things are porous, participating in quiet exchanges with their environment. Loss here is not collapse. It's participation, a slow sharing that keeps everything connected. Some light never reaches anywhere. Not all light finds an observer. Photons are constantly being emitted into directions where nothing intercepts them. They travel through expanding space, growing fainter, stretching longer, and eventually thinning into near indistinguishability. Some of this light will never encounter a planet, a telescope, or an eye. It will simply continue, diluted by distance and time, becoming part of the universe's quiet background. This is not wasteful. The universe does not require witnesses for its processes to be complete. Events do not need to be recorded to matter. Light can exist purely as motion energy traveling, fading, and blending into the larger whole, presence without audience. There's something soothing in that. Not everything needs to arrive somewhere. Not everything needs to be received. The universe allows things to move on without needing acknowledgement, and still considers them part of what is. Rotation is everywhere, from planets to galaxies. Rotation is common throughout the universe. Clouds of gas spin as they collapse. Stars rotate. Galaxies turn slowly, carrying billions of stars in wide, patient arcs. This rotation often begins with tiny imbalances. A slight motion becomes amplified as matter contracts, conserving angular momentum. What starts as barely noticeable becomes a defining feature. Rotation does not rush. Galactic rotations take hundreds of millions of years to complete a single turn. Even smaller systems move with steady restraint rather than speed. The universe seems to favor circularity and repetition, turning without hurry, returning without retracing exactly the same path. If you imagine motion that doesn't aim to arrive somewhere, but simply continues that fits well here, much of the universe moves in this way, content with cycles that are long and smooth without needing resolution. The universe tolerates imperfection. Nothing in the universe is perfectly symmetrical. Stars have spots, orbits wobble, galaxies are lopsided. Even the most orderly systems contain irregularities. These imperfections are not flaws to be corrected. They are expected outcomes of complex processes unfolding over time. Small differences accumulate, variations persist. In many cases, imperfection adds stability. Slight irregularities prevent systems from locking into rigid patterns that could break under stress. Flexibility allows endurance. The universe does not refine itself toward ideal shapes. It allows variation, noise, and unevenness to remain. Structure emerges anyway, or perhaps because of it. That tolerance feels generous. The cosmos does not require exactness to function or beauty to appear. It allows things to be a little off, a little uneven, and still entirely themselves. The universe has horizons. There are limits to what can be seen, even with the most sensitive instruments, because light takes time to travel, and because the universe has been expanding. There is a boundary beyond which information has not yet reached us. This boundary is called the observable universe. It is not a wall or an edge, it's simply the distance light has been able to travel since the universe became transparent. Beyond it, space almost certainly continues, but its details remain unreachable for now. As time passes, this horizon changes. Some regions slowly come into view, Others drift beyond reach as expansion carries them away faster than light can bridge the gap. The universe does not promise total visibility. It allows partial knowledge, framed by time and distance. What lies beyond the horizon is not absent, just unavailable. That sense of gentle limitation feels consistent. Knowing everything is not required to feel complete. The universe remains whole even when parts of it stay unseen, quietly existing beyond what can be touched by light. Stars do not burn like fire. It's common to describe stars as burning, but their light comes from a different process entirely. There is no flame inside a star. Instead, there is fusion nuclei joining together under immense pressure. In ordinary fire, chemical bonds break and reform, releasing energy. In stars, the energy comes from changes at the atomic nucleus itself. Matter converts directly into energy, following simple physical relationships. This distinction matters because it explains why stars can shine for so long. Chemical fuel would be exhausted quickly. Nuclear fusion sustains light across immense spans of time. Even so, fusion is not violent in the way it sounds. It happens continuously and evenly, governed by balance rather than explosion. The universe often uses quiet processes to sustain its brightest features. Light does not require flame. Endurance does not require drama. Some of the most radiant things are powered by steady, invisible exchanges deep within. The universe is transparent in most directions. Space is mostly transparent to light. Photons can travel enormous distances without being absorbed or scattered. This transparency allows us to see far into the universe, gathering light from stars and galaxies across time. In some regions, dense clouds of gas and dust block light, creating dark lanes and hidden structures. But these are local features. On the whole, the universe allows light to pass. This openness makes astronomy possible. It also shapes how the universe evolves, letting energy move freely, smoothing temperatures and spreading influence. Transparency doesn't mean emptiness. It means permission light allowed to continue on its way without obstruction. That openness feels generous. The universe does not trap its signals. It releases them, letting them travel, arrive, or pass through without interference. Movement is not confined. It's encouraged quietly. Energy slowly spreads out. Over time, energy in the universe tends to spread from concentrated regions into wider, thinner distributions. Hot things cool, bright things fade, motion becomes less directed. This process is gradual. It unfolds over timescales that dwarf human history. Stars burn through fuel. Galaxies exhaust gas for new star formation. The universe cools slowly as it expands. This spreading does not feel like loss so much as easing. Sharp contrasts soften, extremes relax. The universe is not collapsing into stillness anytime soon. These changes take unimaginably long spans, but the overall direction remains gentle, not abrupt. There's something calming about that trajectory. Nothing snaps into silence. Everything drifts toward quiet in its own time, without pressure or insistence. The universe does not require observation. The universe does not change its behavior based on whether it is being watched. Stars shine, galaxies turn, space expands, regardless of attention. Observation allows understanding, but it is not necessary for existence. Most events happen without record. Most light travels unseen. Most time passes unremarked. This does not diminish meaning, or it removes obligation. The universe does not perform, it simply continues. You're not required to witness everything happening around you or beyond you for it to be real or complete. The universe is comfortable unfolding without an audience. And you can be, too. Stars can outlive entire civilizations. Some stars live brief, brilliant lives. Others endure far longer than anything we know. The smallest stars, red dwarfs. burn their fuel so slowly that they can remain stable for trillions of years, far longer than the universe has existed so far. If civilizations rise and fall around such stars, the stars themselves would barely notice. They would continue shining at nearly the same brightness, unchanged by eras passing beneath them. This endurance comes from restraint. These stars fuse hydrogen gently, conserving their fuel rather than expending it quickly. Their light is steady, unassuming, and persistent. The universe does not insist that longevity look dramatic. Some of its longest-lived structures are quiet, modest, and easily overlooked. There's something comforting in that patience. Time does not have to rush to be meaningful. Existence does not need urgency to continue. Some things simply remain, offering light without asking how long they will be needed. The universe contains natural clocks. Across space, certain processes act as quiet timekeepers. The rotation of pulsars dense, rapidly spinning neutron stars is so regular that they rival atomic clocks in precision. These stars emit beams of radiation that sweep across space like lighthouse signals. Each pulse arrives with remarkable consistency, allowing astronomers to measure time and motion across vast distances. Other cosmic clocks exist too. The predictable expansion of the universe, the cooling of white dwarf stars, the decay of radioactive elements in space. These clocks do not tick audibly. They do not announce themselves. They simply continue, marking time through repetition and gradual change. The universe does not need a single shared clock. It allows many rhythms to coexist, each suited to its environment. Time here is plural, flexible, and quietly measured, without insisting on synchronization. Most galaxies are small. When we think of galaxies, it's easy to picture enormous spirals like the Milky Way or Andromeda, but most galaxies are much smaller, dwarf galaxies, containing only a few million or billion stars, vastly outnumber large ones. These small galaxies are faint and fragile. Some orbit larger galaxies influenced by their gravity. Others drift alone through space, quiet and dim. Despite their size, dwarf galaxies play an important role. They are thought to be among the earliest galaxies to form. Over time, many merge into larger systems, contributing stars and dark matter. The universe builds large structures from many small ones. Growth happens through accumulation, not sudden appearance. There's a softness to that process. Grandeur emerges slowly, from modest beginnings repeated many times. Nothing needs to start large to eventually matter. Space remembers motion. When objects move through space, their motion leaves lasting traces. Gas clouds carry imprints of past explosions. Stars retain orbital paths shaped by long-gone encounters. Even when an event has finished, its influence can persist. Shockwaves spread outward, orbits adjust, matter rearranges. This memory is not stored in records or signals, it's embedded in motion itself. The universe remembers by continuing differently than it would have otherwise. Astronomers read these memories by studying patterns, unusual velocities, stretched structures, unexpected alignments. History is written into arrangement. Nothing needs to recall the past consciously. The universe carries it forward naturally without effort. What happened remains present as influence, gently shaping what comes next. The universe does not insist on permanence. Stars form and fade. Galaxies merge and change shape. Even space itself expands and evolves. Nothing in the universe appears designed to remain exactly as it is forever. And yet, this impermanence does not create instability. Systems persist through change. Identity is carried forward in altered forms. The universe allows things to end without erasing what they contributed. Matter continues, energy moves on, influence spreads. There is no requirement to stay fixed to be real. Continuity does not mean sameness. If things feel temporary states of mind, moments of awareness, even wakefulness itself that fits comfortably here. The universe does not resist change, it accommodates it quietly, letting everything move on in its own time, without needing to hold on. Light carries gentle distortions. As light travels through the universe, it does not always arrive unchanged. Along the way, it passes through regions of gravity, gas, and expanding space, each subtly shaping it. These changes are usually small, but they accumulate over long distances. Gravity can bend light, stretching or splitting images of distant galaxies. Gas can absorb certain wavelengths, leaving dark lines in a spectrum. Expansion stretches light itself, lengthening its waves as space grows. None of this damages the light, it simply alters how it arrives. The information is still there, carried softly through change. Astronomers learn to read these distortions as clues. Each shift tells a quiet story about what the light passed through on its journey. There's something gentle in that idea. Messages don't need to arrive perfectly to be meaningful. They can be shaped by experience, softened by distance, and still carry truth. The universe has favoured directions only locally. On small scales, the universe has clear directions, up and down near a planet, north and south along a magnetic field, in and out around a star. But on the larger scales, no direction is preferred. Space looks roughly the same in every direction, with no universal up, down, centre, or edge. This uniformity is one of the simplest observations in cosmology. No matter where astronomers look, the universe presents similar large-scale patterns. Local differences matter, global ones fade, orientation becomes relative rather than absolute. The universe does not insist on a single frame of reference. It allows many viewpoints to coexist without conflict. Each place defines its own sense of direction, quietly and without competition. Many stars are part of multiple systems. Single stars like the Sun are common, but many stars form in pairs or larger groups. Binary systems, where two stars orbit each other, are especially frequent. In these systems, stars share gravity, light, and time. Their lives influence one another's evolution, shaping how they age and how they end. Some systems contain 3 or more stars, moving in complex but stable arrangements. Their motion can appear intricate, yet it remains balanced over long spans. Stars do not require solitude to function. Many shine alongside companions, adjusting their paths in response to shared gravity. The universe allows closeness without collapse. It makes room for relationship without forcing merger. Motion adapts, and systems continue. The universe produces more heat than light. While stars and galaxies emit visible light, much of the universe's energy appears in forms we cannot see. Infrared radiation, radio waves, and other wavelengths carry heat and information quietly through space. Dust warmed by starlight glows faintly in infrared. Cold gas emits radio signals. Even planets radiate heat long after receiving energy from their stars. This unseen energy is not secondary. It is a large part of how the universe balances itself, redistributing warmth over time. Light catches attention. Heat sustains background. Together, they form a continuous exchange. The universe does not prioritize what is easily seen. Much of its activity happens beyond direct perception, unfolding gently, without display. The universe remains open-ended. There is no known final chapter written into the universe. Its future is described in possibilities rather than certainty's continued expansion. Gradual cooling, long eras of quiet change. Whatever happens next unfolds slowly. No sudden conclusion appears imminent on cosmic timescales. The universe does not feel like a story rushing toward an ending. It feels more like a continuation, allowing space for what comes after what we know. Open-endedness is not a lack of meaning, it's a form of permission. Nothing needs to resolve right now. the universe continues calmly, leaving room for rest, for uncertainty, and for whatever awareness remains or fades as you listen. Some stars end quietly. Not all stars finish their lives in dramatic explosions. Many, including stars similar to the Sun, reach their final stages slowly and gently. As their fuel runs low, they expand, cool, and shed their outer layers into space. These outer layers drift away as glowing shells of gas, forming what astronomers call planetary nebulae. Despite the name, they have nothing to do with planets. They are simply the soft remains of a star releasing what it no longer needs. At the centre, the core contracts into a white dwarf, a dense, hot remnant about the size of Earth. It no longer produces energy through fusion, but it continues to glow faintly with stored heat. Over immense spans of time, even that glow fades. The white dwarf cools slowly, quietly, without spectacle. The universe allows endings that are calm and unremarkable. Completion does not always arrive with sound or light. Sometimes it comes as a gradual letting go, leaving behind gentle traces and plenty of space. Space is filled with wandering particles. Between stars and galaxies, space contains a thin mix of particles, atoms, electrons, and high-energy cosmic rays moving at great speed. This interstellar and intergalactic medium is sparse, but it is not empty. Cosmic rays originate from many sources: exploding stars, energetic regions around black holes, and other extreme environments. They travel through space for millions of years, occasionally passing through planets, atmospheres, and even bodies. Most pass unnoticed. A few leave tiny traces in detectors or create brief showers of particles high in Earth's atmosphere. These travelers are reminders that motion continues even in quiet places. Space is not still. It is gently threaded with movement. The universe does not separate activity neatly into zones. Even its emptiest regions participate in long journeys, carrying particles that drift without destination or urgency, simply continuing. Galaxies breathe in gas. Galaxies are not closed systems. Over time, they draw in gas from their surroundings, adding fresh material that can eventually form new stars. This gas often arrives along filaments of the cosmic web, flowing slowly and steadily. As it enters a galaxy, it cools, settles, and becomes part of the ongoing cycle of star formation. At the same time, galaxies can expel gas through stellar winds and energetic events. Inflows and outflows balance each other, shaping how galaxies evolve. This exchange happens quietly, over billions of years. There's no clear boundary where a galaxy ends and space begins. The universe seems comfortable with porous systems. Nothing is fully sealed. Matter moves in and out, maintaining continuity through exchange rather than isolation. Some planets wander without stars. Not all planets remain bound to stars. During the early stages of planetary systems, gravitational interactions can eject planets entirely, sending them drifting through space on their own. These rogue planets travel through the galaxy without a sun, cold and dark, illuminated only briefly when passing near stars. There may be billions of such worlds in the Milky Way alone. They move silently, unnoticed, unlit. Though they lack warmth and light, they are not incomplete. They are simply solitary. The universe allows many ways of being a planet. Belonging does not always mean orbiting something brighter. Some worlds travel alone, and the universe makes room for them without judgment or urgency. The universe favours continuity over control. Across everything we observe, the universe shows little interest in precision control. Outcomes emerge from interactions, not from strict planning. Gravity pulls, motion responds, energy flows, patterns arise naturally, shaped by initial conditions and long-term balance. There is no central adjustment correcting every deviation. Variation persists. Systems find stability through flexibility rather than enforcement. This approach allows the universe to remain resilient. Change happens without collapse. Diversity exists without chaos. There is a quiet reassurance in that. Things do not need constant supervision to continue. They unfold, adjust, and carry on. If your attention wanders, if thoughts drift without direction, that too fits within a universe that values continuity over control, allowing motion to soften and awareness to rest wherever it naturally settles. The universe contains echoes of its earliest moments. Long before stars and galaxies formed, the universe was simpler, hotter, and more uniform. Although that era has passed, traces of it remain, woven gently into what exists now. The faint background glow filling space is one echo. The distribution of galaxies is another. Even the relative amounts of different elements carry information about those early conditions. These echoes are not loud reminders. They don't intrude. They exist quietly, folded into the present, shaping what followed without calling attention to themselves. The universe does not sever itself from its beginnings. It carries them forward, diluted but persistent, like a memory that no longer needs to be recalled actively to still have influence. Past and present are not sharply divided here. They overlap softly. What was continues to be present, not as a story retold, but as a condition that remains. Motion can exist without friction. In space, motion does not slow down the way it does on Earth. Without air or surfaces to rub against, objects can keep moving for extremely long times without losing energy. A spacecraft, once set on a path, will continue along it unless acted upon by gravity or another force. Dust grains drift, asteroids follow stable orbits, even galaxies continue their motion largely uninterrupted. This persistence gives the universe a sense of continuity. Motion is not constantly resisted, it's allowed to continue. Change still happens, gravity curves paths, interactions occur, but nothing is automatically brought to rest. There's a quiet ease in that. The universe doesn't press down on motion to stop it. It lets things carry on, conserving what they have, moving forward gently unless something meaningful intervenes. Stars influence space far beyond their light. A star's presence extends much farther than the light it emits. Through gravity, stellar winds, and radiation, stars shape their surroundings in subtle ways. Their gravity guides nearby objects into orbits. Their winds carve cavities in gas clouds. Their radiation changes the chemistry of space around them. These influences overlap. Regions of space become shaped by many stars at once, their effects layering and blending over time. This shaping is not aggressive. It happens gradually, through accumulation rather than force. The universe often works through reach rather than contact. Influence does not require closeness. Presence can be felt from far away, quietly, without needing to announce itself. The universe allows long delays. Many processes in the universe include significant delays between cause and effect. Light takes time to arrive. Gravity's changes propagate at finite speed. Matter responds gradually to new conditions. A star can form from material released by a supernova that occurred billions of years earlier. A galaxy's shape today may reflect interactions long past. Nothing demands immediate resolution. The universe is comfortable with waiting. These delays are not inefficiencies. They are part of how stability is maintained. Gradual response prevents abrupt disruption. If things feel unresolved for a while, ideas, feelings, states of awareness that aligns gently with a universe where outcomes are often separated from beginnings by vast stretches of time. The universe does not require symmetry. Perfect symmetry is rare in nature, and the universe does not insist on it. While some laws are symmetrical, their outcomes often are not. Galaxies have uneven arms. Star clusters form with irregular shapes. Even the cosmic web is lopsided, stretched more in some regions than others. These asymmetries are not errors. They are natural results of chance, initial conditions, and ongoing interaction. The universe does not correct them away. It allows imbalance to remain, building structure on top of it. There is something accepting in that approach. Things don't need to line up perfectly to continue or to matter. Variation is not something to be smoothed out. It's something the universe comfortably carries forward, letting everything exist as it is, and letting you do the same as you listen or drift. The universe makes room for extremes. Across the universe, conditions vary widely. Some regions are unimaginably hot, dense, and energetic. Others are cold, sparse, and nearly still. These extremes coexist without conflict, each occupying its own place in the larger whole. Near the centers of galaxies, stars crowd together, moving rapidly under strong gravitational influence. Far from those centers, stars drift slowly through quiet outskirts. Between galaxies, space becomes even calmer, with only the faintest traces of matter. The universe does not attempt to smooth these differences away. It allows contrast to persist, intensity beside stillness, brightness beside darkness. This tolerance for extremes creates resilience. No single condition dominates everywhere. Change in one region does not require change in all others. There is a gentle reassurance in that diversity. You don't need to be in the most active place to belong. Quiet regions are not unfinished. They're simply part of the same universe, existing fully in their own way. Stars respond slowly to change. Even though stars are powered by immense forces, they do not react quickly to change. When conditions in a star's core shift, the effects can take thousands or even millions of years to reach the surface. Energy moves outward through dense stellar material in a slow diffusion. The star adjusts gradually, maintaining balance rather than jolting into a new state. This delay smooths transitions. It prevents sudden collapse or runaway reactions. Stability is preserved through patience. From the outside, stars appear steady and predictable. Inside, processes unfold at their own measured pace, buffered by layers of matter. The universe often builds stability this way by allowing time to stretch between cause and effect. Responses arrive when they're ready, not immediately. That gentleness makes endurance possible. Space contains long-lived structures. Some structures in the universe persist for astonishing lengths of time. Spiral arms in galaxies last for hundreds of millions of years. Globular clusters remain bound for billions. These structures are not rigid. They are maintained through motion, balance, and continual adjustment. Stars enter and leave spiral arms. Orbits shift. Patterns endure even as components change. Longevity here does not come from stillness. It comes from flexibility, the ability to adapt without dissolving. The universe seems skilled at creating forms that last without freezing. Things remain recognizable while never being exactly the same. That kind of persistence feels gentle. It doesn't require holding tightly. It allows continuity to arise from movement itself, letting structures remain familiar even as their details quietly drift. The universe contains long silences between signals. When astronomers listen for signals from space, they often encounter long periods of nothing in particular. Light arrives steadily, but distinct events bursts, flares. Mergers are separated by vast intervals. These silences are not gaps waiting to be filled. They are the default state. Events emerge from quiet and return to it. The universe does not maintain constant conversation. It allows time between messages, space between interactions. This spacing makes each signal gentle by the time it arrives. Distance and silence soften intensity. You don't need continuous input to remain connected. The universe shows that presence can persist through quiet intervals, that silence does not break continuity, it simply holds it. The universe accommodates many tempos. Across cosmic scales, many tempos coexist. Subatomic particles shift in fractions of a second. Stars evolve over billions of years. Galaxies reshape themselves over even longer spans. No single pace defines the universe. Fast and slow processes overlap without competing. Each unfolds according to its own conditions. This layered timing creates depth. Events are nested within one another, short rhythms embedded in long ones. The universe does not ask everything to move together. It allows each process to find its own speed. If your awareness feels quick at one moment and slow the next, that fits naturally here. The universe has always made room for many tempos at once, letting them coexist without pressure, allowing motion and stillness to share the same space, quietly and without demand. Even large changes begin very small. In the universe, the largest structures often begin as the smallest differences. A slight increase in density within a cloud of gas, a tiny imbalance in motion, a faint variation in temperature. On their own, these changes are barely noticeable. Over time, gravity amplifies them. A denser region pulls in more material. A small motion becomes a rotation. A subtle contrast grows into structure. What begins as almost nothing slowly becomes something distinct. This process is patient. It doesn't leap from small to large. It accumulates. It repeats. It allows time to do the work. Galaxies, stars, and even clusters of galaxies owe their existence to these early, quiet variations. Without them, the universe would remain smooth and uneventful. There's a gentleness in knowing that significance doesn't need to announce itself at the start. What matters can begin softly, nearly invisibly, and still shape vast outcomes. The universe trusts small beginnings to take their time. Space allows paths to cross without collision. Throughout the universe, countless paths intersect. Stars pass near one another. Galaxies drift through shared regions. Particles cross trajectories endlessly. Yet actual collisions are rare. Space is wide enough to allow crossing without contact. Influence often happens through gravity rather than impact, through adjustment rather than disruption. This spaciousness gives motion room to continue. Objects respond to one another without being forced into abrupt endings. Even when paths come close, outcomes remain gentle. Orbits shift, velocities change, systems adapt. The universe seems designed with margin enough room for movement, enough space for coexistence. Not every intersection requires a collision. Not every meeting needs resolution. Many things pass by, altered only slightly, and continue on. The universe keeps many things in balance. Balance in the universe does not mean stillness. It means opposing influences held in steady relationship. Gravity and motion, pressure and collapse, expansion and attraction. Stars exist because inward gravity is balanced by outward energy. Galaxies remain intact because rotation balances collapse. Even the universe's expansion continues alongside gravity's pull. These balances are dynamic. They adjust continuously, responding to change rather than resisting it. Stability here is active, not rigid. When one influence grows stronger, others respond. Systems find new arrangements. Balance shifts without breaking. The universe does not aim for perfection. It aims for continuation. It allows systems to sway, to correct gently, to persist through motion. That kind of balance feels forgiving, strong enough to hold, flexible enough to adapt. Most of the universe unfolds unseen. The majority of what happens in the universe occurs far beyond direct observation. Stars form behind thick clouds. Galaxies evolve in distant regions. Light travels where no detectors wait. Even within our own galaxy, much activity remains hidden, masked by dust, distance, or time. This unseen unfolding is not incomplete. It does not need to be revealed to be real. processes finish their work whether or not they are noticed. Astronomy offers glimpses, not total coverage, and that is enough. Partial views still reflect a universe fully in motion. There's a quiet relief in that. Not everything needs to be seen, tracked, or understood to continue. The universe carries on comfortably beyond awareness, allowing presence without observation. The universe continues without asking anything. At no point does the universe request attention. It does not pause when unobserved. It does not speed up when noticed. It simply continues. Stars shine, space expands, matter moves, time passes. All of this happens whether awareness is sharp, drifting, or absent. There is no requirement to follow every detail, no obligation to stay awake, no expectation of comprehension. The universe seems content to exist alongside whatever state you're in, listening, half listening, or resting entirely. It does not demand participation to remain whole, and that can be enough for now. You can let the facts soften. You can allow the images to blur. The universe will continue gently, whether you're here with it or already drifting somewhere quieter. Stars do not shine alone. A star's light does not remain confined to the star itself. It spreads outward in all directions, thinning as it goes, touching planets, dust, and distant space. Long after it leaves the surface, that light continues on, becoming part of a much larger story. Around many stars, light shapes environments, it warms planets, stirs atmospheres, and influences chemistry, even far from its source. Faint photons still travel, carrying a quiet trace of where they began. In dense regions, starlight overlaps. Multiple stars contribute to a shared glow, blending their influence so that no single source dominates. The universe often works this way through accumulation rather than emphasis. Light does not ask to be noticed. It does not aim. It simply spreads, available wherever it arrives. There's something generous in that behavior. Stars give without direction, without preference, allowing their presence to diffuse gently into whatever space receives it. Even when no one is there to see it, the light continues on. The universe forms patterns without intention. Many of the patterns seen in the universe resemble design spirals, arcs, filaments, but they are not planned. They emerge naturally from motion, gravity, and time. Spiral galaxies form from rotating disks responding to gravity. Rings appear when waves move through matter. Filaments grow where material gathers along paths of least resistance. No guiding hand is required. No blueprint is followed. The same physical laws acting everywhere produce recurring forms, simply because they are stable ways for matter to arrange itself. These patterns are not exact. Each one differs slightly, shaped by local conditions and chance events. Similarity does not require uniformity. The universe allows beauty to arise without effort. Order does not need intention. Patterns can appear simply because they are what happens when things move and interact over long periods, and they remain quietly, without needing to be admired. Space stretches even between bound objects. On the larger scales, space itself expands. Galaxies drift apart as the universe grows, but this expansion does not pull everything away from everything else. Within galaxies, stars remain bound. Within solar systems, planets continue their orbits. Gravity holds these structures together, counteracting the expansion locally. This coexistence is gentle. Expansion operates where gravity is weak. Binding persists where gravity is strong. Neither cancels the other entirely. The universe allows multiple processes to overlap without conflict. Growth does not erase connection. Separation does not undo closeness. There's something reassuring in that layering. Things can remain held together even as the larger context changes. Stability can exist within motion, and belonging can persist even as space itself stretches quietly around it. The universe carries no preference for scale. In the universe, no single size is privileged. Tiny particles and massive galaxies are governed by the same underlying principles. The laws that guide atoms also guide stars. Small interactions accumulate into large outcomes. Large structures influence small details. Scale changes, but continuity remains. The universe does not treat the very large as more important than the very small. Both are necessary. Both participate fully. A single particle's motion can matter. A vast structure's evolution can unfold slowly from countless small contributions. This lack of hierarchy feels gentle. Significance is not assigned by size. Existence does not need to be grand to be real. Everything, from the smallest to the largest, belongs equally to the same unfolding. The universe allows rest between motions. Between moments of change, there are long stretches where very little happens. Orbits repeat. Light travels steadily. Temperatures remain nearly constant. These periods are not pauses waiting to be filled. They are the substance of time itself. Most of the universe exists in these extended states of continuity. Motion does not require constant novelty. Repetition is not stagnation. It is stability. The universe seems comfortable letting things continue as they are for long periods. It does not push toward constant transformation. If your thoughts are slowing now, or settling into familiar loops, that fits easily here. The universe spends most of its time this way, continuing, repeating, resting between changes, and remains entirely whole while it does. The universe is mostly patient chemistry. Much of what happens in the universe is chemical rather than dramatic. Atoms meet, separate, and recombine slowly, guided by temperature, density, and time. In cold clouds between the stars, chemistry unfolds at a pace that feels almost suspended. Molecules form on the surfaces of tiny dust grains. A hydrogen atom drifts close, rests briefly, then moves on. Another arrives. Over time, simple compounds appear: water, carbon monoxide, ammonia. More complex molecules follow, step by careful step. These reactions can take thousands or millions of years. There is no rush. The universe allows chemistry to proceed gently, without urgency or expectation. From this slow chemistry come the building blocks for planets, atmospheres, and eventually life. But the chemistry itself does not aim toward those outcomes. It simply continues, responding to conditions as they are. There is something calming about that patience. Creation here is not forced. It emerges from quiet repetition, from atoms taking their time to find stable arrangements. Nothing needs to happen quickly to matter. Distance softens everything. In the universe, distance has a calming effect. Light fades as it spreads. Heat dissipates. Motion becomes harder to detect. Even the most energetic events lose their sharpness over time and space. A supernova may begin as an intense release of energy, but by the time its light reaches distant regions, it arrives as a faint glow. A gravitational disturbance becomes a subtle ripple. Violence smooths into quiet. Distance does not erase events, it transforms them. It allows intensity to relax into gentler forms. This softening is one of the universe's defining qualities. Nothing remains overwhelming forever. Space itself provides room for things to settle. If sensations or thoughts feel less sharp as time passes, that mirrors a broader pattern. The universe lets distance do its work, easing extremes into something more manageable, without needing to intervene. The universe supports long-term stability. Despite constant motion and change, many cosmic systems remain stable for immense periods. Planetary orbits persist, galaxies maintain their shapes, even clusters of galaxies hold together over billions of years. This stability does not come from rigidity, it comes from balance. Forces counteract each other gently, allowing systems to continue without drifting apart or collapsing inward. Small disturbances are absorbed, adjustments are made, motion continues within safe bounds. The universe seems to value arrangements that can last, not because they are perfect, but because they are resilient. They bend without breaking. There is comfort in knowing that endurance does not require stillness. Things can move, fluctuate, and adapt and still remain themselves for a very long time. Most cosmic light is ancient. Much of the light reaching Earth tonight began its journey long before any human existed. It left distant stars and galaxies millions or billions of years ago, travelling through expanding space to arrive here now. That light has witnessed changes along the way. Galaxies have moved, space has stretched, new stars have formed and faded, and still, the light continued. By the time it reaches us, it carries age quietly. There is no sign of hurry or fatigue. It simply arrives, as it always has, bringing information from another time. When you look at the sky, you're not seeing things as they are now, but as they were. The universe shares its past generously, without asking for anything in return. There is something soothing in that delayed arrival. Nothing demands immediacy. Even the present comes layered with history, softened by time. The universe leaves space for unknowing. For all that has been discovered, much remains unknown. Dark matter, dark energy, the true extent of the cosmos, the ultimate nature of time. These unknowns are not failures. They are boundaries, places where understanding has not yet reached, or may never reach fully. The universe does not seem troubled by this. It continues without needing to be fully explained. Mystery does not interrupt its motion. Unknowing here is not a gap to be rushed through. It is a condition that coexists with knowledge, quietly and without tension. If some things feel unclear as you listen, ideas half-formed, images dissolving before they settle, that fits easily within a universe that makes room for uncertainty. Nothing needs to be resolved tonight. The universe is still here, continuing calmly, whether everything is understood or not. The universe changes temperature slowly. Temperature in the universe shifts over very long spans of time. After the universe first expanded, it cooled rapidly, but since then, cooling has become a slow, patient process. Even now, billions of years later, that cooling continues quietly. Stars provide local warmth, creating small islands of heat in a much colder expanse. Around them, temperatures rise gently, then fall again with distance. Between galaxies, space remains only a few degrees above absolute zero. This gradual cooling is not something the universe rushes. It unfolds at a pace that allows structure to persist. Stars shine, galaxies remain active, motion continues. There is no sudden descent into cold silence. Instead, warmth thins slowly, evenly, without urgency. The universe does not hurry towards stillness. It cools in a way that leaves room for long eras of light and motion. That patience can feel reassuring. Nothing is ending abruptly. Nothing is being pulled away too quickly. Even chaos follows gentle rules. Some regions of the universe appear chaotic. Gas clouds twist unpredictably. Magnetic fields tangle. Orbits become complex. Yet beneath this apparent disorder, simple physical rules still apply. Chaos in the universe does not mean randomness without limits. It means sensitivity, small changes leading to different outcomes over time. Patterns become difficult to predict, but they remain grounded in consistent laws. This kind of complexity allows richness. Diversity of outcomes emerges from simple beginnings. Structure becomes layered, textured, and alive with variation. The universe does not fear this complexity. It does not try to eliminate it. Chaos and order coexist, each shaping the other. There is a quiet permission in that balance. Things do not need to be fully predictable to be stable. They can wander, fluctuate, and and still remain within a larger, steady frame. The universe carries energy gently forward. Energy does not vanish in the universe. It changes form, moves location, spreads out. Light becomes heat, motion becomes radiation, concentration becomes diffusion. This transformation happens continuously and without drama. Energy flows from where it is dense to where it is sparse, easing gradients and softening extremes. Nothing insists on holding energy tightly forever. Everything participates in its gradual redistribution. The universe does not hoard, it shares. Over time, energy becomes more evenly spread, not through force, but through gentle movement. That flow feels calm rather than urgent. Nothing is being taken away suddenly. Everything is simply shifting, finding new arrangements, continuing in quieter forms. Space allows memory without awareness. The universe remembers without thinking. Past events leave imprints in structure, motion, and composition. A galaxy's shape reflects old mergers. A star's composition reflects earlier generations of stars. This memory is not stored intentionally. It exists as consequence. What happened before influences what happens next, naturally and without effort. There is no need to recall or reflect. The past remains present as condition, not as story. The universe does not revisit its memories. It carries them forward passively, letting them shape the present quietly. That kind of memory is gentle. It does not intrude. It does not demand attention. It simply exists, allowing continuity without awareness, a reminder that not all persistence requires remembering. The universe does not mind repetition. Across the cosmos, similar processes repeat endlessly. Stars form, shine, and end. Galaxies rotate. Orbits repeat their paths. Chemistry cycles again and again. This repetition is not boredom. It is reliability. It allows the universe to remain coherent over time, to sustain structure without constant reinvention. Each repetition is slightly different, shaped by context and chance, similar but never identical. The universe does not push toward novelty for its own sake. It allows patterns to continue as long as they remain stable. If your thoughts are looping gently now, or drifting through familiar images, that fits easily here. The universe repeats itself constantly and remains vast, rich, and complete, comfortable with cycles, content to continue, quietly and without demand. The universe allows things to fade gradually. In the universe, fading is rarely sudden. Light dims slowly with distance. Heat dissipates over long spans. Motion eases rather than stops. Even the brightest objects soften with time. A star does not simply switch off. It changes. Its light shifts. Its structure adjusts. Long after fusion ends, warmth remains, lingering quietly as stored energy slowly releases. Galaxies, too, fade gently. Star formation slows, gas thins, bright regions become calmer. Nothing vanishes all at once. This gradual fading allows continuity. Change does not arrive as loss, but as transition. One state becomes another without sharp edges. The universe seems to prefer this kind of gentleness. It lets things dim without erasing them, soften without disappearing. Presence can become subtle and still remain real. If awareness feels lighter now, less defined, less focused, that follows the same pattern, nothing is being taken away. Things are simply easing into quieter forms. Space carries countless quiet trajectories. Every object in the universe follows a path. Some are tightly curved, others stretch long and wide. Many never intersect with anything at all. Asteroids drift through empty regions. Rogue planets travel between stars. Photons cross intergalactic space without ever encountering matter. These journeys can last longer than civilizations, longer than planets themselves. There is no destination required. Motion alone is enough. A path does not need to arrive to be complete. The universe allows these trajectories to exist without supervision or purpose. They are not monitored. They are not corrected. They simply continue. There's a calm freedom in that. Movement without pressure. Direction without expectation. Paths that exist because they do, and that is sufficient. The universe makes no distinction between foreground and background. When we observe the sky, some things appear prominent and others recede. Bright stars stand out. Faint galaxies blur into darkness. But the universe itself makes no such distinction. Foreground and background are matters of perspective, not importance. A distant galaxy is not less real because it appears faint. A nearby star is not more essential because it is bright. Everything exists fully where it is. Distance alters appearance, not presence. The universe does not highlight some regions and dim others for emphasis. It allows everything to exist evenly, without ranking. That sense of equality can feel settling. Nothing needs to stand out to matter. Quiet things belong just as much as luminous ones. Presence does not require prominence. The universe tolerates long uncertainty. Many cosmic questions remain open. How dark matter is composed, why expansion accelerates, what lies beyond observable limits. These uncertainties persist without resolution. The universe does not pause while they remain unanswered. It continues unfolding, unconcerned with whether its workings are fully understood. Uncertainty here is not a problem to be solved urgently. It is simply a condition, a space where knowledge has not yet arrived, and may never arrive completely. This tolerance allows curiosity without pressure. Exploration can continue gently, without needing closure. If thoughts feel unfinished, or questions linger without answers, that fits naturally here. The universe has always carried uncertainty alongside motion, letting both exist together without tension. The universe does not require alertness. Nothing in the universe depends on wakefulness. Stars do not shine brighter when watched. Galaxies do not slow when attention fades. Space does not change its behavior based on awareness. The universe accommodates every state alert, tired, drifting, asleep without distinction. It continues whether you're following closely, loosely, or not at all. You do not owe it attention. You do not owe it memory. You do not owe it understanding. If you are awake, you can listen. If you're drifting, that's welcome too. If sleep has already arrived, the universe will continue quietly alongside it. Everything here is already moving gently forward, without asking anything from you at all. The universe holds vast intervals of sameness. Across cosmic time, long stretches pass where very little changes in any noticeable way. Stars maintain their brightness. Orbits repeat. Temperatures remain nearly constant. The universe is often content to stay as it is. These intervals are not waiting rooms between important events. They are the main substance of existence. Change is layered gently on top of continuity, not the other way around. Even when evolution is happening, stars aging, galaxies drifting, it happens so slowly that sameness dominates experience. Stability is the background condition. The universe does not require constant transformation to remain alive. It allows things to continue quietly, unaltered for long periods, without losing relevance. There is something restful about that constancy. Nothing insists on becoming something else right away. Remaining as you are, for a while, is enough. Motion can be quiet. Not all motion announces itself. Much of the universe moves in ways that are difficult to detect without careful measurement. Stars orbit galactic centers at steady speeds. Gas drifts through space with barely perceptible change. Expansion continues uniformly, without turbulence. This motion lacks drama. It does not rush or pulse. It simply continues. Even large systems can move quietly. Entire galaxies travel through space without sound or visible strain. their motion revealed only through subtle shifts in light. The universe does not equate motion with noise. It allows movement to be smooth, even gentle. If your awareness feels like it's moving without clear direction, drifting rather than stepping that fits comfortably here, motion does not need to be loud to be real. The universe allows coexistence without interaction. Throughout space, countless objects exist near one another without ever interacting directly. Stars pass at safe distances. Particles cross paths without colliding. Galaxies drift through shared regions without merging. Proximity does not require engagement. Being near does not demand exchange. The universe provides enough space for coexistence without entanglement. Things can share a region without shaping one another strongly. This spaciousness reduces conflict. It allows systems to remain stable while existing alongside others. There is something easing in that arrangement. Presence does not have to mean involvement. Nearness does not require response. Things can simply be together without pressure. The universe carries no sense of urgency. At no scale does the universe appear hurried. Processes unfold when conditions allow, not when a schedule demands it. Stars form when gas gathers. Planets assemble when material settles. Galaxies evolve when gravity has time to work. Nothing is pushed to happen faster than it naturally will. Delays are not corrected. Waiting is part of the process. Even expansion proceeds at a measured pace. Time stretches comfortably around events, leaving room for adjustment and balance. The universe does not rush toward outcomes. It allows them to arrive. If you feel no need to move forward right now, no need to finish a thought or stay alert that aligns gently with a cosmos that does not hurry, things happen when they are ready. The universe continues in your absence. Whether you are listening closely, half aware, or already asleep, the universe remains unchanged. Stars shine, space expands, time moves forward. Nothing waits for your return, nothing pauses for acknowledgement, and nothing is lost because of that. Existence here does not depend on participation. It does not thin when attention fades. The universe has always been comfortable continuing on its own before awareness, alongside it, and beyond it. You're allowed to rest inside that continuity. You're allowed to drift. You're allowed to sleep. The universe will still be here, moving gently, doing what it has always done, without needing anything from you at all. The universe carries motion without memory of effort. When things move in the universe, there is no sense of strain attached to that motion. Planets orbit without tiring. Stars circle galactic centers without effort. Light travels without fatigue, crossing vast distances without slowing from wear. Motion here does not consume itself. It does not require recovery. It simply continues, governed by conditions rather than exertion. This is different from how motion feels in daily life, where movement costs energy and rest must follow. In the universe, motion and rest are not opposites. They blend. A particle can move forever unless something changes its path. A star can orbit for billions of years without needing to stop. There is something soothing in that idea. Movement does not have to feel heavy. Continuation does not require pushing. Things can carry on because they are already in motion, not because they are forcing themselves forward. The universe contains layers of stillness. Even in regions full of activity, there are layers of quiet. Inside a rotating galaxy, there are calm interstellar spaces. Inside a glowing nebula, there are cold pockets where little happens. Inside a star, despite intense processes, outer layers can remain steady. Activity does not fill every layer at once. Motion does not penetrate everywhere equally. This layered stillness allows systems to remain coherent. It provides buffers. It softens extremes. The universe seems to understand the value of inner quiet places where change slows, where influence fades, where rest can exist alongside motion. If you notice moments of stillness within your awareness, pauses between thoughts, soft gaps, those are not interruptions. They fit naturally within a universe built from layers of activity and calm, existing together without conflict. The universe does not seek completion. There is no sign that the universe is trying to reach a finished state. It does not appear to be working toward perfection, balance, or final resolution. Processes continue because conditions allow them to. When conditions change, processes change too. Nothing aims to arrive. Stars form and end. Galaxies assemble and disperse. Expansion continues. But none of this feels like progress toward a goal. The universe is not incomplete now, nor will it be complete later. It exists fully at every moment of its unfolding. That can feel relieving. Nothing needs to be wrapped up. Nothing must be concluded before rest is allowed. You do not need to follow things to their end. You can leave processes mid-motion. The universe is comfortable being unfinished and still whole. The universe welcomes fading attention. Attention in the universe is not assumed. It is not required. Most of what happens unfolds without being noticed by anyone. Light travels unseen. Stars are born without witnesses. Galaxies merge beyond observation. The universe does not try to capture attention. It does not repeat itself louder if it is missed. It simply continues. That makes it safe to let attention drift. Nothing will be lost. Nothing will break. You can listen loosely. You can miss parts. You can forget what you heard. The universe does not mind. Awareness can come and go like light passing through space present for a while, then moving on without needing to stay fixed. The universe remains gently. Across all these facts, images, and quiet motions, one thing stays consistent. The universe remains. It remains through expansion and cooling, through formation and fading, through observation and absence. It does not hold tightly. It does not insist. It does not demand. It allows things to appear, exist for a while, and change. It allows rest. It allows drift. If you are awake, you can remain here a little longer. If you're tired, you can let go. If sleep is already close, you can follow it. The universe will continue gently, not louder, not faster, just as it always has. And wherever you are now, awake or asleep, that is already enough. As we come to the end of this long, gentle river of facts, there's nothing you need to gather up or remember, nothing to summarize, nothing to hold on to tightly. The universe doesn't ask for that. It never has. It's still there, expanding quietly, stars moving in their slow paths, light continuing its long journeys through space. All of that continues whether you are listening closely, drifting in and out, or already resting somewhere deeper. If curiosity is still with you, you're welcome to let it linger softly, without chasing answers. And if curiosity has loosened its grip, that's just as welcome. The universe doesn't need to be wondered about every moment to remain vast and complete. You might notice your body settled now, or your breathing slower, or your thoughts thinning out into something simpler, or you might notice nothing at all. All of those states belong here. Awake belongs, tired belongs, sleep belongs. You're allowed to sleep now, and you're also allowed to stay awake, letting the quiet remain without needing to do anything with it. There's no signal you'll miss, no ending you need to witness. The universe doesn't close its doors when attention fades. It keeps going gently, the same way it always has. If this is where you drift off, that's perfectly okay. If this is where you linger for a few more breaths, that's okay too. Thank you for spending this time here, however loosely, however briefly, however sleepily it happened. I'll be here again, and the universe will be here too, steady and unhurried, whenever you return. Good night.